Welcome to lesson 2. In lesson 1, we prepared everything. We downloaded all of the tools. We pulled the Docker image. We pulled the repository. So everything has been set for our Dockerized ROS2 environment. You didn't really have to install ROS or Ultralytics or anything like that. So let's talk about YOLO and Ultralytics today in lesson 2. So we're gonna be using YOLO, which is a state-of-the-art super fast and accurate object detector. And Ultralytics is a company that provides optimized versions of it and makes it very easy to install and use, but you don't have to worry too much about the installation part. It's ready for you to use within the Docker. And in particular, we're going to be using YOLO 11. So let's jump straight to it. Before we can do anything ROS related with YOLO, though, we first need to study what a standard YOLO pipeline or YOLO script looks like. So we're going to be doing that in this lesson in preparation for ROSifying that and using it with ROS. So a few things. So in the past lesson, you downloaded this repository, so you should have these files. And by the way, this thing, I'm going to remove it because I just ran this earlier and it downloads this model, but I want to show you what it looks like when you just download the repository. So you should have these files. And then we are going to now run the container. So let's open a terminal. And the first thing you need to do is to go to the root folder of that repository, and we confirm that it has the files that it should have, just like this. And now we're going to run the container, and the first thing to do is we need to run this line to authorize access to the GUI of the host machine. Okay, otherwise when we run ROS and we try to visualize the detections, it's going to fail. So this will give the container access to the local computer's screen system or windowing system. Okay, now I'm going to run the container. And by the way, just briefly, this is how you run it. So Docker run interactive. It's going to remove previous sessions if there were any. This is important. We're giving the container a name because in later lessons we're going to open multiple windows and we're going to attach them, or terminals, sorry, multiple terminals, and we will attach them to the same container and run different things from different terminals. This is related to the display, so we're going to use the display resolution and the display system of the local machine. And this is important. This will say that the current folder, which is this, which contains this, will be mounted as the volume. That volume will be mounted into the workspace folder of the container, which is this one. And then this is the image we are launching, right? So back to this part. All of these files or this folder will be mounted into workspace, but also the container has been instructed to directly take us to ROS2 folder, right? So this didn't happen magically. It was just the instructions that we gave the container say, take us here because we'll be working mostly with ROS, but not today. Today we want to go one step back and confirm that from the container we can still see the same files, right? This was from the local machine, and this from the container. You can tell that, and we have access to the same files. We have access to the YOLO detector, and we have access to an MP4, which is a dashcam footage or recording showing a particular drive of a car in a busy city. And we're gonna do object detection on this video. So let's go straight to it before we jump into the code. So Python 3 YOLO detector, and once you run this, the first is gonna download the YOLO model. It's gonna take a little while, and once it's ready, it loads that video and does the object detection. So here's the object detection in action. And I'm gonna get out of here. Let's look at the code. So I'm gonna open VS Code. If you open that root folder, and then you can see the YOLO detector. Let's quickly go over this code. So this is a class that implements a standard object detection script in Python. And we start with the constructor, where we just set everything up. So here in the constructor, we say what's the model we're going to use, which has been already downloaded. You can see it here. It's not part of the repository, but once you run the script the first time, we'll download it. Then what is the video we're going to use, which is here. And then we give the window that will show the detections a name. And here we just say we're loading the model, and then we try to actually load it. And if everything goes okay, we say that we did successfully load it. If something goes wrong, the try except will catch that and just tell us what failed. Sometimes maybe you gave it the wrong name, the wrong path, or something like that. And then we open the video capture, which depending on what parameter you pass here can be either your webcam or a video. In this case, it's a video, so it's this video. And then if everything is okay, if something goes wrong, we say that something went wrong and just return. And things that can go wrong is that you pass the wrong video path, so the video doesn't exist. But assuming everything went well, we just say that everything is ready and that we're about to start the loop. Then there's the loop function here. And what it does is that this has been opened already here, right? This has been initialized. So while this guy remains open, or the video capture remains open, it will keep on looping and giving us one frame at a time. And if something goes wrong, it will go to this return value. So if we check that if not return, so this will be none if there's no image. So if there's no image, it's likely that we reach the end of the video and we just break out of the loop. Otherwise, we have an image here. And then we can run it through the model. So here we do the inference or the YOLO detection. And then we will get a list of results, but normally it's just one result. But if there are more than one, the first one is the best one. So we just get it is a list. So we get the index 0, which is the first. And that will be the result. And this result is a Ultralytics object, special objects that has a apart from having the results, it has some functionalities like the plot, right? So if we call the plot function on this result, it will do something very nice for us. It will just draw all those bounding boxes and labels on top of each detection, which before with older Ultralytics or other libraries, sorry, we had to do by ourselves manually with OpenCV. Ultralytics has this very convenient plotting function that does that for us and returns us a annotated version of the image of the frame, which we can directly show with OpenCV. That will open a window that has this name that we set above in the constructor. And then if at any point we press Q, this will just quit and break us out of the loop. And that's it. And then there's a cleanup function for when we stop our script. It will release the video, what's it called? I always forget, the video capture. It'll release the video capture and it will destroy all the windows to make sure that everything is clean and exit cleanly. So when we run this script, we are triggering the main function, which starts by creating an instance of that class above, right? This is outside of the class. So it creates an instance of the class above. So this calls the init method that initializes everything, right? And then once the object is ready, we just call the run loop function, which will go over the images and do the detection. And if we press Control C or something else goes wrong, so this try except will catch it, and it will just shut everything down and call the cleanup function. And that's it. The pretty straightforward, pretty simple YOLO script that is cool for telling your friends that you can use YOLO and showing them, and they will be like, wow, this is cool the first time they see it. But other than that, it's useless, right? We're just showing the detections, but we're not doing anything useful with them. So in lesson 3 and up, we're gonna turn this into a ROS node and do something more useful with it. But for now, for this lesson, all we wanted to do was to understand a typical YOLO script so that we can know later how to ROSify it. Good. So let's look at it in action one more time. And there it is. So again, it opens it sets up the YOLO model, opens the video capture from the video we provided. In a loop, it will get frame by frame. Every frame is passed through the YOLO detector. It gives us results. Those results we can use the object to plot, which will give us this image with these boxes and the labels and the scores. And then we just show it in this window, YOLO detections with OpenCV. If I press quit, it exits. And then it says the video capture has been released and Windows closed. And that's it. Pretty simple. So see you in the next lesson to start turning this into a ROS2 node. See you next time.